So this is nothing but refraction through multiple mediums, where you have three different mediums, 1, 2, 3. So where this is going to be air, this is going to be water, and this is going to be glass. Okay, so now what we are going to do is, we are going to have the incident ray which is passing first from air to water. Okay, so it is going to pass like this with an angle of incidence I. And then what will happen? Rarer to denser. So what will happen? Bending towards the normal. So it bends towards the normal, and this is going to be angle of refraction. Okay, let me take it as I1, R1. Now what happens? After water, it is going to reach glass. Okay, so again, rarer to denser, because glass is somewhat denser than that of water. So the bending of light, so this, let it be, can I take it as I2? Instead you can take it as R1 itself. We know pretty well that is going to be the equal, no? Parallel. Now it is going to bend towards the normal again. So this is going to be R2. Okay, this is going to be R2. Now after that it is going to come out, right? So in this case this is going to be I1, because according to glass slab conditions, the angle of incidence is equal to angle of emergence. அதனால நான் ஈக்குவலா இங்கே எடுத்துக்கிட்டேன். ஓகேவா? ரைட்? எஸ். ஸோ இப்போ இதில் let us name it A, B, C, D, E. ரைட்? அண்ட் நார்மல்ஸ் அப்படியே இருக்கட்டும், ஒன்றும் பிரச்சனை இல்லை. இப்போ ஃபர்ஸ்ட் கண்டிஷனை பொறுத்த வரைக்கும், செகண்ட் கண்டிஷன், தேர்ட் கண்டிஷன்ஸ் எல்லாம் பொறுத்த வரைக்கும், யூ கேன் கோ ஃபார் ஸ்னெல்ஸ் லா. ரைட்? ஸோ வாட் யூல் கெட்? ஃபர்ஸ்ட் கண்டிஷனில் mu12, because the first medium which is going to make the refraction happen is second medium, or refractive index of second medium with respect to first medium. So what you'll get? Sin I1 divided by sin R1. Let this be first equation. அடுத்து 2 ல இருந்து 3 க்கு போதா? 2 ல இருந்து 3 க்கு போகுதா? Right? So in this case what you'll have? Sin R1 divided by sin R2. Right? Okay, and then third length marivi 1 ku varudha, so it is going to be sin R2 divided by sin I1. Yes, you can multiply all these three equations now. So what you'll have now? Is equal to sin I1 by sin R1 into sin R1 by sin R2 into sin R2 by sin I1. Everything will cancel, right? So sin I1 cancels, sin R1 cancels, sin R2 cancels. So it becomes equal to 1 now. So mu21 into mu23 into mu31 will be equal to 1. Right? So in this case you will easily find out what is going to be the refractive index of second medium with respect to first medium. Likewise, you can also find out what is going to be the refractive index of first medium with respect to third medium. Okay, but the task is to find out this. Why? Whenever you are considering refractive indexes, basically நம்ம என்ன எடுத்தோம்? refractive index is nothing but velocity of light in vacuum to that of velocity of light in medium. அப்போ vacuum வச்சு medium குள்ள போறத கண்டிஷனை தான் நம்ம refractive index அப்படின்னு எடுத்தோம். There are certain standard values of refractive index. Say for example, if you have refractive index, if you want to know what is going to be the refractive index of glass, it is 1.5. Refractive index of water, 1.33. Refractive index of vacuum, 1. Refractive index of air, 1.0004. So these are all going to be the standard values with which we have considered the reference as a vacuum. When the light travels from vacuum to glass, the refractive index of glass with respect to vacuum or air is equal to 1.5. Okay, the refractive index of water with respect to air is 1.33. So whatever we have taken, we have considered the reference as standard values like air or vacuum. That is easy pretty. Okay, so in this case also the light is going to travel from air to water. So if you want to know what is going to be the refractive index of water with respect to air, we can easily find out. Okay, but the challenge is, what will be the refractive index of glass with respect to water? Water வந்து கிளாஸுக்கு வருது, கிளாஸ்னால தான் பெண்டிங் நடக்குது. ஆனால் அதுக்கு முன்னாடி எதில் இருந்து வருது? ஏர்ல இருந்தோ வேக்யூம்ல இருந்தோ வரல. எதுல இருந்து வருது? வாட்டர்ல இருந்து வருது. அப்போ refractive index of glass with respect to water has to be found. In that case, you can use this. Now, simple நான் சொல்றேன் பாரு. Let us consider first medium as air, second medium as water, second medium as water, third medium as glass, third medium as glass, and first medium as air is equal to 1. I want to know what is going to be the refractive index of glass with respect to water. What I can do? Refractive index of glass with respect to water can be done like 1 by refractive index of water with respect to air into refractive index of air with respect to glass. You will know only this because reference value should be standard value. Refractive index of water with respect to air can be easily found, but refractive index of air with respect to glass will be a difficult task. For that only we have reversibility formula. So I can replace this as mu GA divided by mu WA. How? Since mu AG can be done like 1 by mu GA. Correct, Appa? Yes. So now we have found out what is going to be the refractive index of glass with respect to water as refractive index of glass to that of refractive index of water. Is that clear? இது ஈஸியாக நான் வச்சுக்க, சிம்பிள் தான். refractive index of glass with respect to water தானே, எது இங்கே இருக்கோ அது நியூமரேட்டரில் வந்துடணும். Okay? If you want to know what is going to be the refractive index of water with respect to glass, refractive index of water to that of refractive index of glass. See, when you are considering the refractive indexes of any medium with respect to air or vacuum, you don't require to mention it as air or vacuum. You can simply write it like mu G mu W. If it is going to be with respect to some other medium, we have to mention that as either glass or water or mica, whatever you take. Okay, right? So do you understand what is this? Right? So if you have multiple mediums and if I want to know what is going to be the refractive index of a particular medium with respect to the unknown medium, we can go with this formula. Is that clear?